Hi, everyone. My name is Paul Needleman. I'm a senior solution architect with Snowflake, and I'm here to do a demo on Snowflake-managed Iceberg Tables and how you can use the Snowflake open source SDK to read those tables within the Databricks environment. So without further ado, I'm going to jump into the demo and walk through this with you. And before I just want to also know that there is a blog on this as well. We will be sharing the link to. So any of the code that you're seeing, we will have available through the blog. All right. So the first thing we're going to do for folks who are not familiar with Iceberg, just kind of give a quick overview of the SDK. So this is a different blog and just kind of shows a nice picture of the Snowflake catalog SDK. So real quick, Snowflake has now Iceberg Tables in public preview as of early December. That allows Parquet and the Iceberg metadata to be saved or stored within your customer storage, so S3 or Azure Blob Storage, and make that data accessible to other engines. So the Parquet is written out to S3, but you also need to have access to the catalog. So this is where the catalog SDK comes in. It's an open source project that we worked on, and allows right now Spark to be able to read from our Iceberg catalog, the Snowflake-managed catalog. So today we're doing, instead of using an open source Spark environment, we'll be using a Databricks environment to configure the ability to read from the Snowflake-created Iceberg tables. So this is essentially what we're going to be doing, just replace the Spark logo with Databricks. So the first thing we're going to do is going to go into Snowflake. We're going to create our tables. To do that, the first thing we do is we create an object called an external volume. So I have a new database here called IceDB, and we will run that. We are going to switch to account admin, create the external volume. This is already created, so I'm not going to recreate it again. But essentially, you would if you're used to creating a storage integration, it's very similar. You just pass your location to the bucket and the ARN for your role. And then you can you'd be able to see your external volume. You describe your external volume. And this is for AWS environment. And you'll pull out the information there to go put into your S3 or AWS environment, your bucket policy, so you can then have a trust policy or trust relationship between Snowflake and S3. Optional step here would be to create an Iceberg, to create a stage. I think it's kind of helpful to have this so you can view your files. You obviously can go into your storage provider, such as S3, and look at those files, but I think it's nice to just be able to look at them through Snowflake. So you create that. I just ran an LS on that, and it is empty. So there's no files yet. There's no data. All right. So I'm going to create some fake data. To do that, I have a Faker open source Python library. I'm using Snowpark Snowpark with the Faker library and package enabled. And essentially what it does is makes it really easy to create nicely unified, just formatted data. So I'm going to create 50 million customer records. So I'm going to use a 2XL real quick just to get that moving quicker. It's a great thing about Snowflake is you can just scale up and scale back down. So let me just generate these records. So take about a minute here. Double check my login to S3. While this is running, I'm just going to check on that. So I have to log back in here because I got timed out. All right, so now I'm in here and this table is creating. Again, it should take about a minute or so to generate all this fake data. Just to know, when I'm creating this Iceberg table, so I'm obviously using the faker package. I have a UDF. The faker package is being called for first name, last name, email. It generates really, again, nice synthetic data. When you create the table, there's kind of two main components that you need to specify for Iceberg tables. Again, this is going to be a Snowflake-managed Iceberg table. And the managed part means that the catalog, what we're talking about before, of who's kind of managing the metadata, is going to be managed by Snowflake. So the first thing is just passing the Snowflake parameter to catalog. And then the second part is going to be your external volume. And that is the external volume Iceberg is the same name that we specified previously when we created our external volume called Iceberg. So those are really the two main pieces to create an Iceberg table. And then what you're also going to do is specify a path, and here the base location is customer, and you'll see that in a second. Now this is just finished creating, and we can do two things. One, go back to that LS I was just running, where my stage was empty before, and now you can see a path with customer in it, because I gave that prefix to customer, and then all the Parquet data that was generated behind the scenes. And then if I refresh my bucket, I now have a customer directory, and in that directory I have both data. There's a lot of objects here because it's a pretty big table, so that's loading here still within AWS, so you can see this is generated. And then there's also a metadata file folder, and this has got all the snapshot information, the Iceberg metadata that's being used by our catalog. It's exposed and will be used by the SDK as well. All right. So one last step here in Snowflake, I'm going to create a second table just called transaction, same exact thing. Only difference here is I'm going to have a base location of TXN. So it's going to create a TXN prefix on the bucket. I'm creating for every 50 million customers, I'm creating 20 transactions. So, and I think it's actually 5 million, excuse me, it's 5 million customers with 20 transactions. So it's going to be quite a large amount of transactions that are being created here. I still have my 2XL running. As soon as this finishes, I'm going to scale that back down to just a regular extra small warehouse. So for this file, we have transaction ID, the customer ID is going to be joined, right? So we're joining to this Iceberg customer table that's just generated, so we can have a foreign key relationship. Number, date, quantity, price, transaction description. So just a way to grab some measures, some fact level information, if you will, so we can do some aggregation against the customer. Let that finish, and then we will jump into Databricks. All right, so 100 million transactions have been created, and we can go now and see what this looks like. One other quick thing before we move on, there was one other site that needs to be done within your environment. Again, I'm in AWS, so you're going to need to configure your user and provide a secret. So real quick to show what that looks like from AWS. Obviously, if you're in Azure or GCP, it's going to look a little different in how that integration works. Before your user, you would create a secret that could be leveraged. And that secret's going to give access to Spark or Snowflake, Databricks, in this case, to access your S3 files. So your security credentials here will have the ability to then be used within Databricks. So let me fire up the cluster here. While that's running, takes a while to start, I will kind of walk through the configuration settings. All right, so here's my cluster. It's starting. In my blog, I use 10.4 version of Spark. Really, you can use any version of the DBR, Databricks runtime. The main thing to note is when you do change your Spark environment, obviously there are different libraries, so we'll start there. So there's 3 libraries we're using. I just got them from Maven. One is the JDBC, so that's going to connect and authenticate to Snowflake. Really, any version here should work. You also have the AWS bundle. This is more for connecting to S3. Again, just match that version to your version of Databricks. Shouldn't really make a difference. The one that makes, it really matters is the Iceberg Spark runtime. This is going to match to your version of Spark. So because we're running 14.2, it's a 3.5 version of Spark, so we need to use that version to match. And if you're not sure when you pick your DBR, it says right here Apache Spark 3.5 Scala 2.1.2, and that's the version of the Iceberg runtime that I selected. All right, I'm not going to talk about the Databricks different items. I think folks can kind of choose for themselves what size of worker and how many. I just put 4. I think that's pretty configurable. The main part here, though, and this is also in the blog, in terms of the exact setting. If you go back to this blog here, we do have some sample configurations of how to connect to the Snowflake SDK or Iceberg catalog. I've used some of these. I've also configured a few of them myself specifically for AWS, and I'll show you that now. So the things that we need to configure. Let me zoom in a little bit. You're going to need the username and password for your Snowflake environment. You're going to need this right here, the Snowflake catalog implementation for how we're implementing the data. And so for this environment, we're using AWS S3 file input outputs. That's why we need to have that library for the AWS. This will be different if you're not using AWS. And then there are some Spark catalog is going to be defined here. That is from the blog we were just looking at, as well as the Snowflake environment that you're connecting to. And then here is going to be your AWS region, your secret that we just talked about to authenticate the user to access that S3 data. All right. I think that's mostly it. Let's see if the Databricks environment is up. Still starting. One other thing to note, this is if you're keen and kind of seeing right here in the corner, we are in Azure Databricks, so it's pretty cool that this is an Azure environment, and we are using AWS for storage, and there's no compatibility issues because Iceberg's an open format, and then the catalog SDK really transcends cloud providers. So pretty cool to see that. Still waiting on cluster to start here. All right, and the cluster is up, so we are now going to take a look and try to read the metadata the data through the SDK and this Spark catalog that this is old, so let me clear this out. All right, so the first thing we're going to do is use the Snowflake catalog, and we are going to clear all shell output so it's not distracting. And we're going to view the catalog from Snowflake and view the different databases that are available to us. Cluster's up, it's just taking a minute here. So actually, I'm going to remove this IceDB for a second. So you can see when you use this show namespaces in the Iceberg catalog, this is going to read Snowflake's database to see where are their databases available to query. IceDB, if you remember, is the database that's available. There's also a Snow Sandbox that I have active, but it's not used for this demo. So for this demo, we're going to use the IceDB. So we're going to show the namespaces. And then here you go. The main one here is information schema in public. Tables I created did not specify a schema, so they were created in public. So now we're going to use the IceDB database public schema and then view the tables that are available to us. And there you go. You can see that there are the two tables that we created just a moment ago. This is, again, reading from the Iceberg catalog and showing the tables that we had just created previously in Snowflake. So just to quickly validate that you can view that data, just doing a select star, limit 10, just to get some data back. And again, all these files are sitting in AWS, created from Snowflake, and the snapshots and all the metadata is registering in the Snowflake catalog, Iceberg catalog. All right, so there we go. We've got our data back. This was generated through Snowflake, made available on S3, and now it's being read in Azure Databricks. And of course, if you want to do a more complex query and start joining data together, that is obviously possible. Here, we're just going to get a bunch of data for each state. It's listed here, and then join to the transaction and determine what is the total price of sales, essentially, for each state for all time. And so our Spark job is running now using Databricks Compute to calculate that. All right, and now it's calculated 50 seconds to calculate the number of total price or total sales per state for every state that was available in our data set created for Baker. One of the things I wanted to note, I guess two remaining things. So one is you have the ability to use data frame style API, what's available in Spark. So again, just going and doing a show, which is, getting your top 10 or 20 records. You could use obviously any data frame operation here that's available in Spark too, but we're obviously reading the Spark Tables Iceberg customer, so pretty simple. We're now leveraging this Iceberg table within our data frame. The next thing is I just wanted to show how easy it is to update. So if you recall right now, if I were to do a count on this table, and I'm already in here, I can just do a quick count. It shows 5 million records, right? So if I jump back into Snowflake and I do an insert, and let's say we want to insert 100,000 records. So let me bump up. We're still using 2XL. I will do my insert. Should take not too long here to insert those 100,000 records. Again, it's using the Faker library again, so it's going to go and use that UDF to go and generate that fake data on top of the row generator here of 100,000. All right, so 100,000 records were inserted, and then without having to do anything, we go back into Databricks. I'm going to rerun this command, which is going to go get the table from Snowflake that's coming again, sitting on AWS, and we're just going to run the same count again and see that number increment, hopefully. And there we go. We now have the extra 100,000 rows that were inserted without having to do anything. Snowflake has written that data, registered the updated snapshot from Iceberg into the Snowflake catalog. And because, again, we're using this catalog from Snowflake, Databricks is able to immediately register the change data because it's transparently knowing which snapshot to point to from the SDK catalog. All right, so that is it. Wanted to thank you all for watching. Again, we will be publishing or be posting the link to the Medium blog that has all the code that you can use to follow this exact same demo. And thank you again so much for your time, and feel free to reach out or leave any comments for any questions or feedback that you have. Thanks so much. Bye-bye.